We have a flow chart here where we're going to have propene and we're going to add bromine. So if it's an addition reaction to an alkene, I'm going to land up with a haloalkane. Somehow I can land up with just an alkane, and that would mean that I would just have to add hydrogen to that. And over here I can take decane, which is a longer chain, crack it, in other words, do an elimination reaction and get propene as a product. So that's what this flow chart is representing. Identify the IUPAC name for substance A. Well, if I was going to take propene, and make it into propane, I would have added bromine. So the double bond would have opened up and I would have put one bromine over there and one bromine over there. So it's 1,2-dibromopropane. So if you need to identify the type of reaction that occurs at reaction A, that's going to be an addition reaction. Another way of saying that addition reaction is that it is a halogenation reaction. That's more specific because I've added a halogen. Chemical reaction taking place when decane forms propane is called cracking, and it is an elimination reaction. So it says to find the term cracking. It is when long carbon chain, hydrocarbon chains, through an elimination reaction become short alkenes, and they in the process release what other substance? Hydrogen is released during the reaction. And then it asks the boiling point of propane is very low, minus 42 degrees centigrade, whilst propanol is 97, so that's much higher. So it says use your knowledge of intermolecular forces. So let's identify the intermolecular force first of all. And we've got propane, which is a non-polar covalent molecule. And that means that it is held together by London forces, which are weak intermolecular forces and therefore a low boiling point, as opposed to propanol, which has a polar characteristic at the alcohol and therefore is held together by dipole-dipole intermolecular forces. It's a polar covalent molecule, and that has a much higher boiling point.